Remember that the square root of 4 was 2, because 2 is the number I have to square to get 4. And remember that I said that you can write 4 as 2 squared, and that then the squaring and the unsquaring cancel each other out, leaving you with just the 2. Well, this squaring and unsquaring are called inverse operations. I can actually take any number and square it and unsquare it, and I'll get that number back. What's more, it doesn't matter whether I square it first and then unsquare it, or whether I unsquare it and then square it. I'll still get the same number back. Here's what I mean. We've already taken a number, squared it first, and then unsquared it, and got the 2 back. What happens if I take 2 and unsquare it first, and then square it? According to this, I should still get 2, but how can we check that? Well, squaring something means multiplying it by itself 2 times. So the square root of 2 squared looks like this. In the last part, I told you that you could take a product that was inside a square root and split it up so that it would look like this. If you can split it up, then you can also put that product back together under a single square root. Now that I have my product under a single square root, I can write the product and then take the square root. Or even more, I could rewrite this as 2 squared under the square root. So in fact, these two things are equivalent. In this case, the exponent's on the outside. We took the square root of 2 first, and then we squared it. In this case, we squared 2 first and then took its square root. But we end up with 2 as our answer in either case. That works for cubes as well. Let's take 5 and cube it and uncube it. Take the cube root. One way to think of this is that cubing and uncubing cancel each other out. Again, regardless of whether I take the cube root first and then cube it, or cube the number first and then uncube it, the cubing and uncubing cancel each other out, leaving me with just the number inside. Cubing and uncubing are inverse operations. They undo each other. The idea of inverse operations is very important in algebra. You'll see it again and again and again, and in fact, you'll see it later again in this quarter. Some of the problems that deal with inverse operations that you'll be working with in later math classes are much, much more complex. But the idea is still the same. Inverse operations undo each other. Subtraction and addition are inverse operations because subtraction undoes addition. Multiplication and division are inverses because division undoes multiplication. And multiplication undoes division. Try not to think of them as opposites because that means something else in mathematics. But inverses undo each other or cancel each other out.